The two main things we're going to be looking at here for our applications are what we call angles of elevation and depression, where this does not mean that our angles here are enlightened or sad. We're talking strictly about position. That an angle of elevation is an amount up and an angle of depression is an amount down. So we'll get a little bit on one of each of these to understand how we can use them and how they fit into the scheme of trigonometric functions. First, suppose you look up at an angle of 57.2 degrees and a distance of 125 feet at the top of a tower. Estimate the height of the tower. So here, what we've been given is, in terms of that picture, an angle of elevation looking up, along with a base that is a length adjacent there of 125 feet, and we want a length opposite. So we're given an angle, adjacent and opposite. That means we have two of the three pieces for dealing with tangent. As important as anything here is being able to recognize the patterns that our values fit into, where, well, tangent tends to be kind of obvious, but we'll see what happens here, and we'll see what happens with the next example as well. That in this case, we have, by our defined relationship, tangent of 57.2 degrees has to be equal to the value a that we are looking for over 125 feet. So, rearranging, multiplying that is, we get that a is equal to 125 times tangent of 57.2 degrees, where on an exam, this is actually the sort of answer I'd want, because unfortunately 57.2, as I said, the real world doesn't fit into nice patterns, and that doesn't come close. So if we wanted to get a value here, it would have to be something with the calculator, it would have to be something very approximate. For an exact answer, this is good, but to get a approximated value using the calculator, we could plug some things in there and get that the height of the tower would end up being about 194 feet. Still pretty straightforward. The main thing there is being able to recognize that we have two of the three parts for tangent. We have adjacent and the angle, and want the opposite. If we wanted the top length across, then we'd have to think a little bit more in terms of something like sine or cosine, in this case cosine, because we would have adjacent and opposite, or not adjacent and opposite, adjacent and would want hypotenuse, but again, it's all about building those connections to understand here what we have and what we need. So, let's finish off the section, let's finish off this chapter with one more similar flavor of example. For this, suppose a 21-meter tall building casts a shadow of 25 meters. Find the angle of elevation of the sun to the ground. Well, one other thing to mention here is that with these problems, you're not always going to be given the picture. And if you have something like this on an exam, what I would strongly recommend is sketching up the picture. I don't expect it to be quite that good. I don't expect it to be good at all based on the sort of skills that you've seen from me when it comes to artistic ability. But if you put something on there where it's clear to me that you understand what you're meant to be looking for pictographically, I'll still give you a good chunk of the credit, because that shows me you're thinking about these things in terms of the right sort of geometry, even if you maybe whiff on which function to use when. So for this one, we are given the height and the, base width there. We're given the leg lengths, and you want to find the angle of elevation, in this case, the angle up, where if we want to get an angle in terms of opposite and adjacent, that ends up being tangent of A is equal to 21, the height over 25. That is the opposite over the adjacent. And with these types of problems, it's often a good instinct to think maybe tangent is useful for them. It's not guaranteed, but it's usually a decent place to start. Anyway, this is what we have here, where technically speaking, we need to be a little bit tricky and use a thing called an inverse function, inverse tangent, here to get our value for A, that A is going to end up being about 40 degrees, because this is not a perfectly nice value. If we want to get that maybe a little bit more exactingly, a little bit more carefully, we could, using some rearrangement, some cleverness there, but really we'd still end up dealing with the calculator to get our final value. So if a question like this was on the exam, I would give you really just on all of the points for having that sort of picture and having this relationship properly defined. your ability to use a calculator with an inverse tangent function isn't so important to me as being able to know what you're meant to find and what piece will tell you what you're looking for. If you can do that, then you're fine in my book. There are other situations in which you'll need to get calculator practice. There are other situations maybe in which you'll need to get inverse tangent practice, but you have other things to worry about here. So that's all we've got. If you want to get some more extra credit there, if you want to think some more complex ideas, you can go on and look at 10.7, but that's not going to be on our exam. So good luck getting prepared, and we'll talk a little bit about that next week. After that, we'll get going onto our last unit, looking at things with probabilities and statistics. But until then, good luck, and I will see you in a little while.